Here to talk about automotive safety with our Andy's RISC-V IP cores, and we'll also cover a little bit of security offering that we have. So I'm going to talk just a couple minutes about automotive trends, a little bit about ISO 26262, and our functional safety and security solutions. So in the automotive industry, and you probably all see this, there are a lot of changes going on across the chain: drive-by-wire, vehicle communications, electrification, trending towards software-defined vehicle in the future. And that's really changing the electronics architecture in the vehicle. Things have moved from legacy independent ECUs to today, where there's a lot of domain trending towards zonal controllers and eventually towards central vehicle compute. And this is causing a lot of increase in software complexity as well. Today, we're probably over 1.2, 1.5 billion lines of code running in a vehicle, so it's getting and increasing exponentially. So this is actually a great fit for RISC-V. RISC-V is the one architecture that can be optimized across all these different use cases, scale from small MCU class ECU controllers all the way up to high performance multi-cluster application class central vehicle compute processors. And why do we need functional safety in vehicles? There's been, quite a few incidents throughout the years. I don't know if anybody remembers Toyota unintended acceleration that ended up costing Toyota probably north of $1.5 billion. Anybody remember Takata airbags inadvertently deploying? You'll be glad to know that there are only about 6 million of them still left on the road. Okay. And obviously, Tesla has gotten some news with their fatalities with autopilot and crashes for those sort of autonomous systems. Okay, functional safety, at its essence, is really the absence of a level of unacceptable risk due to a malfunctioning system. Okay, and this is measured by ASIL, Automotive Safety Integrity level, and various systems in the vehicle have different ASIL levels. The more critical the system, the higher the ASIL level. Okay, so if you look at like airbag, actually an airbag not deploying is like ASIL B because it hardly ever happens, but an airbag inadvertently deploying is ASIL D because you're exposed to it very frequently. Okay, get through this. All right, so functional safety failures are classified into two categories. The first category is systematic failures. Those are failures that can be prevented through design. Okay. The other category of failures are random failures. These are not preventable. In systematic failures, the way to prevent those from ISO 26262 perspective is through a safety culture, safety process, and safety management. And ISO goes and specifies a number of processes in a company that need to be followed through the life cycle of a product to adhere to the safety culture. On the random failure side, the ASIL level specifies effectively a failure in time. So the highest ASIL level of ASIL D would have less than 10 failures in time, or less than 10 in 100,000 years. Okay? And it's really important that both systematic and random failures be covered. There's actually different processes for this, and there's certification bodies that certify to a certain ASIL standard level. Andy's has been very early on in qualifying both its design processes, the systematic part. Back in 2020, Andy's was completely certified to have an ASIL D certified design process, and then using that design process to roll out RISC-V cores that are also ASIL certified. So currently, we have a couple of ASIL cores from our 25 processor family. These are both ASIL-B certified at this point, fully compliant. And for the first core, we've already had customers that have gone and gotten their end products. So they've used this IP, they've produced silicon, and then they've gone to certifying authorities using our deliverables and got their end product certified as well. Okay. We've actually just released today our D45 SE. That will be ASIL-D certified. We've released our D23 SE. That will also be ASIL-D certified. And coming next year, we're planning on releasing our out-of-order applications core ASIL certified. So this gives us coverage from ECUs all the way up into central vehicle compute with ASIL certified RISC processors. Also coming really soon, we'll be releasing an automotive qualified hardware security module. And just to touch on the features, all the cores have baseline protection features, ECC, some hardware status, and there are additional safety mechanisms. They're protected by a watchdog timer, and they come with software test libraries to reach ASIL-B levels. The cores that are ASIL-D certified do have dual lockstep implementations for full coverage. And all the ASIL cores are delivered with a functional safety manual. We also have a full complement of partners for our automotive ecosystem that offer, ASIL certified compilers, operating systems, security modules throughout for the full SoC design needs. We've had a lot of customer success. In fact, we've had over 10 customer licensees for our ASIL certified cores. 5 of those, actually about 7 of those now, are in mass production, and over 2 of them have already been ISO certified with their end products. Just to touch on security, vehicles are becoming more and more connected. They have attack points all over the vehicle, and it's not like a data center that you could protect somewhere just behind, some communications wire. You leave your vehicle with a valet, you take it into a mechanic, it could be attacked anywhere. There are numerous security standards starting to evolve. What we've done in response to this is we provide kind of a wraparound security framework. It begins with our RISC-V processors that are inherently secure with the RISC-V security features. We wrap that in a secure platform with common peripheral IP. We integrate with security solutions from our partners. And we have also been a contributing member of RISE, providing software solutions such as an MCU, Trusted Execution Environment, and OPT. And coming pretty soon, in the next couple of months, you'll see announcements on our automotive-grade hardware security module with that integrates all these with a partner, with the secure platform, and the software. Okay, so I think my summary message to you guys is, RISC-V is really well suited for automotive. Right? It can span from ECUs up to central vehicle compute from the processing performance needs. Automotive safety is a hard requirement, and it needs to be through the entire design chain. The IP supplier, the chip manufacturer, the modules maker, to the vehicle end system. And security is essential across automotive, and we're addressing those needs as well. So I wanted to thank you for your time. Appreciate it.